Hey there. My name's Richard. I'm the CTO at a company called Cleat, and at Cleat, we're developing Threeport. And Threeport is an open source application orchestration system that is an alternative to pipeline-based delivery systems such as traditional continuous delivery or CD or GitOps. These pipeline delivery systems are woefully inadequate at deploying, delivering, managing modern cloud-native software, and Threeport is a control plane that orchestrates the delivery of an application with all of its dependencies. And in this video, I'm going to provide a demo of how Threeport does that. So this demo is for practitioners, which is to say developers, DevOps engineers, platform engineers, to show you what's involved in using Threeport. And my hope is that after seeing this video, you'll want to try out Threeport for yourself. And if you would like to do so, just go to threeport.io, and there's a link to the GitHub repo for Threeport, and you can just download the command line tool that I'm going to use in this demo and try it out. And our documentation link here will take you out to our docs site, and there are all the guides and walkthroughs that will allow you to do the exact same things that I'm going to do in this demo. If you run into any questions or feedback that you want to provide as you do it, you can link to our Discord channel right here. Just hit us up and provide any feedback or ask any questions that you have while you're doing it. So with that said, I'm going to jump over to my terminal. And the first thing I need to do is to spin up a Threeport control plane. So the command to do that, and I already have tpt-cuttle, which is the command line tool for Threeport that you can download from GitHub. And I'm using version 0.5.1, which is the latest available version on GitHub right now. And in order to spin up a new control plane for Threeport, I just need to provide this command, which is tpt-cuttle up. You can see the flags that I'm passing in. I'm giving it an arbitrary name. I'm calling it demo. And I'm specifying that I want to use the EKS provider, which is to say it will be installed in AWS. You can also install Threeport control plane locally using Kind on your workstation. And because I'm spinning it up in EKS on AWS, I'm passing in the AWS region, which I have set as an environment variable, which is just US East 2. So when I hit this command, tpt-cuttle up, it's actually accessing the connection credentials that I have set up using the AWS command line tool. So in order to spin up a control plane for Threeport in AWS, as long as you have an AWS account and you have installed the AWS command line tool on your machine, and you've set up your connection credentials and configuration locally, then tpt-cuttle will use those same configurations and credentials to connect AWS and spin up all the resources that are needed to run a Threeport control plane. So you can see from the output of the command here that it's spinning up right now some networking infrastructure, and it is then going to install an EKS Kubernetes cluster using AWS. And then once that cluster is available, it's going to install the Threeport, all the components of the Threeport control plane, which I'll show you when it's up and running. At this point, I'm going to pause the recording because it's going to take a few minutes for all of the resources in AWS, including the EKS cluster, to spin up. So I'll resume when that's done. All right, I just got back from making myself a coffee, and as you can see, our Threeport control plane is now created, and it took about 16 minutes, which is about par for the course. So what happened here, just to review, we issued the tpt-cuttle up command, and it created all of the AWS infrastructure necessary for a Threeport control plane. And you can see here at the end here, we've got an EKS cluster creation is complete, and the Threeport control plane is installed, and our local Threeport config has been updated, which includes the connection credentials for us to securely connect to that Threeport API so that we can use Threeport to manage Kubernetes clusters and workloads. At this point, I'm going to just issue the AWS, use the AWS CLI to update my local kube config with the new EKS cluster that we have running. And you can see I have the region and my AWS profile set as environment variables. And I think the name of that cluster is correct, but I'll just check. Yep, it will be. And this, once my kube config is updated, we'll just jump over to K9S and we'll take a look at what is in this cluster. And this will illustrate the components of the three-port control plane. So this is my EKS cluster. And you'll notice our three-port control plane namespace has the three-port API server. We use Cockroach DB as the data persistence layer for the state in Threeport. And we also use NATS Jetstream to help broker notifications from the API to all of the various controllers, which you can see listed here, in order to manage workloads and their dependencies. So one thing I didn't touch on, which is important, is that Threeport manages all of the dependencies for a workload to deliver it. That includes the compute infrastructure on AWS in this case, the Kubernetes runtimes, the Kubernetes clusters for those workloads to run in. It also includes any managed services that your application may have a dependency on as a part of its application stack. This would be things like RDS databases or S3 buckets. It also manages the support services that run in Kubernetes, and you're going to see this in just a moment. Kubernetes by itself is not a complete application platform. It needs a lot of support services in order to service the applications, and we call those support services. That would include things like managing network ingress, TLS termination, DNS records, secrets, so on, observability, so on and so forth. And Threeport supports all those systems in order to deliver your application. So at this point, what I'm going to do now is I'm just going to call the TPT call commands we use from this point forward will be calling the Threeport API to either get information or to create new objects that will result in a running workload. And first, I'm going to get a list of all of the Kubernetes runtime instances we have available to us. So we just spun up a Kubernetes cluster in order to install the three-port control plane. And therefore, we have this Kubernetes runtime instance called Threeport demo available to us. That's the same cluster that the three-port control plane is running in. So we can use that to deploy workloads too, which is what we're about to do. If you wanted to use a dedicated cluster for your three-port control plane and then deploy workloads to different clusters, perhaps in different regions, even on different cloud providers once they're supported, you can do that. And I have a demo config for a Kubernetes runtime. If you wanted to add another Kubernetes runtime in order to deploy workloads to, you simply pass it a configuration that looks similar to what you see on the left here. And we've just given this runtime an arbitrary name. We've specified the infra provider as EKS. I have some commented alternative infra provider fields here for when we have support for spinning up Kubernetes on Google Cloud or Microsoft Azure. We don't have support for those yet, but we plan to add it later this year. And that's an example of how we can abstract the cloud provider and just allow someone to spin up a Kubernetes runtime and nominate which cloud provider they wish to use. And we have a few other fields here that declare the account that wants the cloud provider account the user wants to use, whether or not they want a highly available Kubernetes cluster, the node size for the default node group, the node profile, and the location is a three-port abstraction that allows someone to specify a location that on the back end, Threeport will translate into the appropriate region for the individual for the location. And I just realized that, oh no, this is correct. So the North America Chicago location will translate to the US East 2 region for AWS. But we're not going to spin this cluster up anyway. We're just going to use the existing one because we'd have to wait another 15, 16 minutes for that new cluster to come up before we could deploy. Instead, we're going to use this workload configuration to spin up a sample application, which is just a basic WordPress app in this particular case. So this is the configuration file for the workload. And I'm going to go through and explain what all of those things mean in that configuration in a moment. But first of all, I'm going to create a workload and reference that config by name, which is WordPress workload remote. And when I issue this command, it's going to make a call to the Threeport API and create that workload with all the details that you see on the left. The Threeport control plane at that point is going to orchestrate the creation of any managed services that are declared, any support services that are declared, and install the Kubernetes resources that are needed in order to run that application. So when I hit this create workload, first of all, I'm going to jump over to my AWS console and illustrate that there are no smoke and mirrors involved here. So I'm going to open up Route 53. You can see on EKS, if we go to the console, once it loads, we can see our Threeport demo cluster. This is the one where the Threeport control plane is used, and also the cluster where we're going to deploy our sample workload. And you can see we have no S3 buckets available just now. If I go to Route 53 and go to a hosted zone called cleat.net that we use for testing and demos, you'll see that we don't have any subdomains or DNS records. We just have the basic records for DNS here, nothing for a specific workload. And in RDS, we're going to use RDS as the database for this WordPress application. And you can see that we have no databases deployed at the moment, nor do we have any secrets, except we do have a secret, but we're not going to use this secret. We're going to use a different secret. So you can see WordPress demo secret 0 here, which is left over from a previous demo, but we're going to create a new secret. And AWS Secrets Manager will store some secrets for the WordPress application that it will access. All right, so if we go back to our terminal, we've got this tptctl create workload command staged up. And again, we're referencing this config file that you see on the left. So when I hit enter, tptctl is now calling the Threeport control plane, and it's creating that workload object. And you can see it says Threeport workload WordPress created. So if we jump over here to our Kubernetes cluster, you can see that Threeport is now installing Cert Manager, external secrets, and it's installing those so as to configuring them for the application so that we can manage secrets, we can manage TLS assets, and you can see our Getting Started WordPress pod has also been created. Now, when this WordPress pod comes up, it's actually going to fail to start because it is waiting on a database. And that database is being created, and it's going to take a few minutes to spin up. Once that database is available, Threeport will take the connection credentials, including the unique endpoint for this database, and the connection credentials, and provide it to the WordPress app as a secret. So in a moment, we'll see that the WordPress application will hit a create container config error because that secret is not yet available. But that secret will be available when that database is available and the information that goes into that secret. So we can also see here that Glue Edge, to be specific, has been spun up, and that's going to manage network ingress. And again, Threeport is installing that support service and configuring it for the workload that we need to run. Just as a point of interest, in the support services system, we use this support services operator. And this is the interface between Threeport and the Kubernetes cluster. We run that support service operator in every Threeport managed Kubernetes cluster, and it manages the installation and configuration of all of the support services that are running, like Cert Manager, Glue Edge, external secrets, so on and so forth. So while that's working, we're going to come back over to this workload config, and I'm going to step through what this workload configuration consists of right now. So first of all, we have just an arbitrary name for the workload. We've just called it WordPress. We have a reference to a YAML document. Now, this YAML document is just a conventional Kubernetes manifest. And one of the objectives of Threeport is to abstract away the complexity of Kubernetes. And right now, this is a stepping stone that will always be available to users to provide a manifest. But very soon, I'll be providing a demo that abstracts away the necessity to provide all of these details that are in this Kubernetes manifest. And what that will look like is this. So this demo is coming soon. And this right here is a fictional configuration, but soon I'm going to provide a demo using the Threeport SDK, not yet released, but coming very soon. And this SDK allows anyone to build a custom extension to Threeport that can leverage all of the underlying primitives that are in Threeport. So essentially what you'll have is with this configuration, which just has managed database true, which is to say, let's use RDS for the database. If this is false, we'll spin up a MySQL database in the cluster, which may be more appropriate for development environments. We're going to specify how much storage we need on that database. We'll specify the tier of deployment, which will indicate things like how many replicas of WordPress do you want to run? Do you want to run horizontal pod auto-scaling for that WordPress? And then the domain name and subdomain that we would like to use for it. Declare the Kubernetes runtime instance and account that we want to use, and that's it. So at this point, we have a true developer level interface that will allow developers to self-service the delivery of their own applications and have all of those things plumbed together. But for this demo, we're using a more granular configuration that includes the manifest. We're declaring the runtime instance that we want to run, and that's that Threeport demo Kubernetes runtime instance that we have. We're also saying, hey, we want to run an RDS database as the persistence layer for WordPress. So please spin up a WordPress database using MariaDB, not MySQL, sorry. MariaDB, specifying that 20 gigabyte of storage and say we want an extra small machine size. If in that other abstraction we specify production, we'd use a larger machine size for the database. And this workload secret name is, we're telling Threeport, this is the name of the secret that we want to expose to the application. And we need to tell WordPress in the Kubernetes manifest which secret that is. We're saying we want an AWS storage bucket. We're really not, WordPress really isn't going to use it, but this demonstrates that we can spin it up as a dependency for any workload that does want to use S3. And here we're saying we want to use a domain name, and I have this cleat.net hosted zone in AWS, as you saw. And I'm saying, let's use that hosted zone for the DNS record for this particular application. And if we jump all the way to the bottom, we're going to say, let's use the subdomain blog. So once this application is up, we'll be able to directly go to blog.cleat.net and see our application running and available on the public internet. Right here is where we declare the secret that we want to use, and I'm using WordPress demo secret 1 and what those environment variables that are being exposed to the application will be. So this secret means that Threeport doesn't store the secret. It will take the admin password and the SMTP password and directly translate it straight into the secrets manager in AWS without being persisted anywhere in Threeport, so that the secret is stored there. And then we expose using external secrets, which is essentially a Kubernetes controller that links that secret into the application. Using external secrets, we'll expose that secret to the application so that it can have those secrets available. Lastly, we have a gateway declaration, which essentially means, hey, I want traffic from the public internet to be available to my app. I want to expose port 80 and redirect traffic on that port to 443. And TLS enabled true says, hey, give me some TLS assets using Cert Manager. And in this case, we're using Let's Encrypt. Important to point out that for this demo, we're using the Let's Encrypt staging environment. So the certificate that is generated and provisioned for the application won't be publicly trusted, but I'll be able to tell my browser to trust it anyway because I trust it. And we'll be able to view the application once it's up. All right, so if we jump back over here to our cluster, we can see all our support services are up, including external DNS, which is managing DNS records for us. And our database must be ready to roll because our WordPress application is now running. So let's just double check what we have over here in AWS. So our S3 bucket is available and it is connected to our application. So if you wanted to put static assets on S3 to be available to the public internet, you could absolutely do that. If we refresh our cleat.net hosted zone, we can see now that we have our subdomain that has been provisioned and our database is now available. And in our secrets, we also have our WordPress demo secret 1, the contents of which are being exposed to the WordPress application. So long story short, at this point, we can just go to blog.cleat.net. And as I said before, we're using the staging environment, so I need to tell my browser to trust that certificate, and our application is up and running. The thing that I want to really point out and double down on here is that this is much, much simpler than the toil involved in managing templating and configs to spin up Kubernetes resources, not to mention the support services that are needed in the cluster and need to be configured for that application. It also manages, and those templates and configs can number in thousands of lines in many environments, not to mention the AWS resources, which many organizations use Terraform for. Not needed. We don't need to manage all of those thousands of lines, or at least hundreds of lines of Terraform config for RDS and S3 and all these other, and these dependencies for the application. Furthermore, when using Terraform, you need to capture the output from Terraform, which includes things like the endpoint for the bucket and the endpoint for the RDS database, and then plumb it into the resource configurations for the Kubernetes resources. Threeport as a control plane application orchestration system is superior in that it manages all of those elegantly within a single control plane. These variables are not having to be moved around through some kind of script glue for your CD pipeline. They're just passed in as function calls or passed through the API to other controllers to manage those things. And one more thing I'll point out is that Threeport is extremely modular in that the AWS controller is responsible for managing all the AWS managed services like EKS itself, RDS, S3, so on and so forth. The workload controller is responsible for interfacing with the Kubernetes API to spin up Kubernetes resources, the secrets controller for the secrets, so on and so forth. The gateway controller for the gateway support services. And what this allows us to do is modularize Threeport in such a way that you can add custom abstractions using the soon to be available Threeport SDK. And when we add support for other features like GKE and GCP, we will simply add a new controller that handles that domain and that set of concerns with a distinct controller. And all of these controllers coordinate with one another through the API server. And the last thing that I do want to point out, the one thing I would like to illustrate here is if I do tpt cuttle get workloads, it lists out the WordPress demo app that we just deployed, and you can see that right here. But you can also see the other workloads that were deployed and managed by the gateway controller and the secrets controller in order to support this application. So in many organizations, a platform team has to spin up your Kubernetes clusters and install all the support services to make them ready for workloads to be deployed. But with Threeport, we actually manage those support services into the cluster in response to a requirement by an application. So our gateway controller deployed the Glue Edge and external DNS components into the cluster, and it installed them as Threeport workloads. The secrets controller deployed and configured the external secrets component into the cluster, and you can see them all listed there when we get workloads. So it's one thing to be able to orchestrate all of these dependencies when you spin up a workload. It's another to clean it all up. But because all of these resources are recorded in the Threeport database, and for what it's worth, it's recorded down to the resource ID in AWS. It's all recorded in the Threeport database. So Threeport has all of the information that it needs in order to spin these things down. So the first thing we'll do is we'll delete the workload instance, and we'll call it out by name, and it's WordPress. And so now we're just going to delete the application that we deployed. The important thing to see here is that we're not just deleting the Kubernetes resources, we're also deleting the S3 bucket, the RDS database, the DNS records. We're cleaning up all of those dependencies for the user when they delete the workload, because again, we have all those dependency maps stored in the database, and we can now jump over the AWS console and see those being cleaned up after us. So if we refresh this, I can see that my authentication has timed out. So I need to jump back in. And when the page loads, we can go back into the RDS console. And we can see that for the database instances, our WordPress database is now being deleted. We'll check our S3 bucket. And our S3 bucket is gone. If I ask for a list of buckets, no buckets come back. Our S3 bucket has been removed. Our secret will not have been removed. So this is important because, and this is why I had a dangling secret from a previous demo. Deleting an instance of an application does not delete a secret that's associated with it. And we do it that way so that if there are secrets that are dependent upon multiple applications, it will remain there. In order to remove the secret itself, we still have our WordPress demo secret right here. And this is just in case you want to use it with another application, because some secrets are depended upon by multiple applications. However, we can now just delete this secret if it's no longer needed. And we'll delete it by name. And this will remove the secret from AWS altogether. So I don't recall how quickly this happens, but there we go. It's pretty much instant. The one thing that's not instant is the DNS record. External DNS sometimes takes a minute or two to help me out here, AWS. The DNS records sometimes take a moment or two to be reconciled by external DNS, but I think it's been long enough. So if we check now, we can see that our DNS records have been cleaned up too. So not only were we able to orchestrate the provisioning of all these resources, we can also orchestrate the deprovisioning and the deletion of all these resources as well. So that concludes the demo. I hope this was useful. Oh, the one other thing I will add is deleting the Threeport control plane is as simple as using the tpt down command. What that will do, it will take all of the resource inventory, and the resource inventory for the control plane is actually not stored in the Threeport database because that's about to be wiped away. All of the resource inventory for the Threeport control plane itself is actually stored locally next to the Threeport config that tpt uses to authenticate to the Threeport API. So when we run tpt down, it will use our local AWS credentials, connect to the AWS cluster, delete the Threeport components, and tear down all of that infrastructure that we saw above get created. So everything that was created above here, that'll all get torn down so that you can be assured that that you don't have dangling resources that you're paying money for. Now, the caveat here is that we still have these workloads running, and by default, you cannot delete a Kubernetes runtime while there are workloads still provisioned. So when I finish this demo, I'll go through and delete those workloads. Once those workloads are deleted, I'll run tpt down and it'll be all cleaned up and I'll have a clean AWS account again. So thanks for taking the time to watch this demo. I will reiterate that if you want to try out Threeport, just jump over to GitHub. The Threeport project is open and available to the public, and you can click on our releases and download the tpt binary for your architecture. And then our documentation, which is at docs.threeport.io, includes a bunch of architectural and conceptual documentation, but as well, it also includes obviously install information, but it also includes the guides to do exactly the things that I did in this demo. And again, if you have any questions, just hit us up in Discord. Thanks again for watching.